All right, let's do this. Okay, so you're driving around a curve with a radius, blah, blah, blah. Okay, so this car is going to go in a circle like this, yes? And there's the car, right? In order... What? Terrible circle? Dude, don't judge me.
Wait, no, I'm talking about my circle. I looked at my circle to yours.
That's all right. I hate it when people say that. So judge as much as you want. That's fine. What has to happen for this car to move in a circle? What must be supplied? Oh, wait, don't answer. Let me call out the stress inducer.
Stress inducer.
Huixin. What must be supplied for this to go in a circle? Wait, it's still like a lot of time left. We have like 10 minutes left. 15 minutes left. That's wrong. Okay, so Huixin, what has to be supplied for anything in the universe to go in a circle? Good, centripetal force. Now, here's the interesting thing. What is supplying centripetal force in this problem?
Not friction.
Not friction. In fact, this problem is kind of stupid. Because if there's no friction, how is the car moving? So clearly, this car has a jet engine.
Did you see one of those cars though? Like they tried to explain it.
Is it like in
Okay, so this, even though it looks like a tank firing backwards, this car,
Have you seen one of those like truck races where they have like a jet?
yeah, they literally have like a giant, like ram jet engine in the back. Yeah, so this car has some sort of fan or jet engine pushing it around because there's no friction. So what is keeping this car in a circle? Because it isn't friction. Does have something to do with the earth. Angel, what do you think? Normal force, it is associated with normal force. So she's on to the heart of it. Here we go. Let's say, I don't know, whatever we're going to do, the car here. Okay, so okay, so there's my car. Okay, now if we do a force diagram on the car, is everybody cool with this? Does that make sense? So which of those arrows, Fn? That's terrible. My mouth said something. My fingers did something else. Mg cos theta, Mg sine theta. Which one of those is making that car go in a circle? Brandon, I already talked to Brandon once today. Alex always talks. Gracie. Okay, so does Mg, so this car, do you see that Mg, like Fn is coming out like this? Mg cosine theta is going in like this. Which one of those is pointing towards the center? Which one is giving us this?
Oh, MG.
There you go. Does this make sense to you? Now, be careful. Take a look at this. Does everyone here realize that this, like this, okay, is retarded? This is going to be F sub c. F sub c is going to be something pointing towards the middle. Is all of Mg sine theta pointing directly at the middle? No, it is not. So in fact, what we have to do is this. Just that part is pointing towards the middle. So let's do this on another drawing so it can be a little bigger and let it be clear. So if we make this box our car, and we draw this like this is not drawn to scale. So this is our Mg sine theta. Do you see that we're breaking Mg sine theta into two pieces like this? And if that's theta, then this has to be theta. So what is that? If this is Mg sine theta, what's that? It is Mg sine theta cos theta. Okay, now everyone's like, what the heck? Relax. If this was F, what would you call that? Wouldn't you just call it F cos theta? So whatever this is, you just plug it in to that, multiply it by cosine theta, and that gives you the adjacent side. This just happens to already be mg sine theta. The fun part is this one is mg sine squared theta. But that doesn't matter to us, right? For us, we know that f sub c is equal to mg sine theta cos theta. And what does f sub c always equal everywhere, any place in the universe? So it's mv squared over r equals mg sine theta cos theta. Notice the abbreviation there, sorry, I ran out of room. So I cancel the m's. What are we looking for? The velocity, right? Yeah, what maximum speed? So we need the speed that keeps us there. So we get v is equal to the square root of r g s theta cos theta. And when you do that, you're going to get the square root of like, I think around 160. And then that's 4 times 3.13, so that's like 13 or something. It's close. That's not exactly the right answer, but. Okay, questions? That's a fun one. It's not as fun. I probably wouldn't do that on a quiz because that's like conceptually harder. The other one is tediously difficult, right? The first problem requires like the classic things we've been learning since August. So that's probably the one you're going to see on a quiz. Hint, hint, nudge, nudge, wink, wink. Okay, hug.